Hey everybody, Mr. Wada here, and today we're going to be going over double bonds, triple bonds, and isomers. So I was looking at the answers that a lot of people had for last week's assignment, and I just wanted to do another practice exercise on what we did last time, just because there were some difficulties with the double bond example. So first, the answers to last week's work. You had N2H4 and nitrogen is in group 5. And if you draw nitrogen out, what you'll see is that you get nitrogen with 5 valence electrons. And I already know how it's going to look, so I'm organizing it a specific way. We're going to have 2 here, 1, 2, 3. Okay, so there's 3 electrons by themselves there that are unpaired. Those 3 free electrons make bonds. So that means nitrogen can make 3 bonds. And we know there's 2 of them. So I'm going to put another one here. And I know that these 2 are bonded. So that covers my N2. That part's done. Now I need 4 H's. So if I'm going to have 4 H's, there are 1, 2, 3, 4 electrons that are left unpaired. So here's your H, 2 on the top there, 2 on the bottom there. And hydrogen only having 1 valence electron, I know that I can just draw the line here because each of them would just have 1 dot. And those dots would all connect with the lines that I just made. Next up is H2O2. The one that goes in the middle is oxygen. That's because oxygen has 6 valence electrons. And with 6 valence electrons, that means there's 2 bonds. So you've got your oxygen. 1, 2, 3, 4, 5, 6. And then you have another oxygen here. Same, I'm just going to mirror it. Okay, so there's a pair on the top and the right on this oxygen, and there's a pair on the top and the left over here. Oxygen bonds in the middle. Hydrogens both have 1 electron because hydrogen, element number 1 in group 1. Bond like that. And the actual shape in real life would be like this would be rotated that way, but it's easier to draw it this way. And then the last one here is N2H2. And as I mentioned at the top of here, this one has a double bond. So if you look on the left, N2H4, there's 2 less hydrogens, and there was a single bond. I'm going to organize it the exact same that I did last time. And I'm going to attach 2 hydrogens. Okay, well, now I've got 1 bond in the middle here, but I've got these 2 electrons that are left at the top. When you have electrons that are sitting there by themselves, they bond. So that is going to bond there. That is a double bond. So you got 2 bonds. 1, 2. All right, now for the new stuff for today. Got a couple of examples to do. So we're going to do CO2, N2, C2OH6. And then your assignment is going to be to draw SiS2, CH2O, and 2 isomers of N2SH4. That last one's going to sound really confusing until you see this example. So CO2 has a double bond, and instead of using the dots this time, I'm going to make it easier by just counting the number of bonds. Carbon makes 4 bonds, and oxygen makes 2 bonds. Okay, so we know carbon makes 4 bonds and oxygen makes 2. So carbon makes more bonds, so that's going to go in the middle. And I'm just going to use the lines now to connect them instead of using the dots to show the electrons. So carbon is going to make 4 bonds, goes in the middle. We know we have 2 oxygens. Those are going to have to go on the outside then. How can we possibly connect these so that we use up all of the bonds? Because each oxygen needs 2 and carbon needs 1. So you're going to start by connecting the elements together. All right. Are any of the elements happy with what they have? No. Carbon needs 2 more bonds and both oxygens need 1 more. Well, if I add another bond here, it's a double bond. Now my oxygen has 2. Carbon has 3. That's a problem. This oxygen over here also only has 1. So if we do the same thing here, we get CO2, 2 double bonds, and it's all set. Next up is N2. Nitrogen makes 3 bonds. So I'm going to draw my 2 nitrogens. And if you do the actual Lewis diagram for this one, you end up with 2 pairs on the outside, and then you have 3 free electrons. Well, just like we did in the previous examples, we're just going to connect the ones that are next to each other. This is called a triple bond. And then for the last example, we're going to go over something called isomers. Isomers are basically just different versions of the same chemical in terms of where the parts are arranged. When you get to molecules that are a little bit larger and you have more parts, it's possible to move the different elements into different sections. So for example, we have carbon. Carbon makes 4 bonds. Oxygen makes 2 bonds. And hydrogen makes 1 bond. First, which element's going to go in the middle? Well, first one we're going to write is carbon, because carbon makes the most. And then you might ask yourself, okay, well, what should I put next? You have a couple of options here. You could put oxygen or you could put carbon, because you could put the oxygen between the carbons or you could attach it at the end. So I'm just going to start by stringing together all of the pieces that I can. I've got 6 hydrogens. We know those have to go on the outside because they can only attach one time. They can't go in between things. So I'm going to put my hydrogens here. And now I've got 3 of them done. And I have 1 carbon done. That means I have 1 carbon, 1 oxygen, and 3 hydrogen left. Okay. I could just put another carbon here. If I put the next carbon there, now I have both carbons done, and I have 1 oxygen left I have to put, and I have 3 hydrogens. Okay, well, if I put the 3 hydrogens here, I don't have oxygen. So oxygen has to go next. Now I have 3 hydrogen left. Oxygen makes 2 bonds. We've only made 1. Let's put a hydrogen at the end. Okay, oxygen now has 2 bonds. Oxygen's all set. Carbon. Carbon needs to make 2 more bonds. And if you count up the hydrogens, we have 1, 2, 3, 4 so far out of the 6. So if we put the last 2, we're done. Well, except we're not, because there's more than one way we could draw this. We could also take this oxygen and switch it with the carbon here. And if you do the exact same thing, drawing it that way, you would have the same arrangement, except you would have the oxygen in the middle. So if you just add your hydrogens on the outside, do the exact same thing as last time, you can see that there's more than one way that you could arrange that. And all the atoms are happy there because the carbon has 1, 2, 3, 4 bonds, 1, 2, 3, 4 bonds, and the oxygen has 1, 2. Okay, so hopefully at this point you've seen that you can arrange these a couple of different ways. Your assignment for today is to try and draw SiS2, and SiS2 is going to be similar to to the example up there. You have CH2O, which is sort of similar to this one, only there is one way to draw it, and this has a double bond. So this has one double bond. And then the last example here says draw two isomers of N2SH4. This example is going to be very much like that one up here.